We're going to go through a couple concept questions that are specifically related to this concept of beats. So make sure you answer the question on your own first. So pause the video, determine your answer, and then watch the solution. Feel free to reach out to me, please, if you have questions, though. So here's the first question. So the correct answer here is A. So in pair 1, we're seeing 1, 2, 3 beats in this specific time frame. But pair 2, we're seeing just barely 2 beats. So 2 beats per second, 3 beats per second. That beat frequency is the absolute value of the difference between the two frequencies you're listening to. So the larger the beat frequency, the larger the difference in the frequencies that you're listening to. And again, the beats are the loud to soft, loud to soft, loud to soft. It sounds like the wah-wah-ing. All right, one more question. Oh dear. Here is our one more question. What do you think about this one? So the correct answer here is B. So we're hearing a beat frequency of 2 beats per second. We would also represent that as 2 hertz, but it does make sense to put it in terms of beats per second. Beat frequency is simply the difference, the absolute value of the difference between the 2 sound waves you're listening to. We're told this one is 500 hertz. So the frequency of source 2 is either 498 hertz, because 500 minus 498 is going to give us 2, or it's 502 hertz. It's going to be one of those. The determination of which one is from the wording here. It tells us the beats disappear if source 2 moves towards us while source 1 remains at rest. So this goes back to the Doppler effect. We hear a different frequency based off of the motion of an object. Since this source 2 is moving towards us, we're going to hear a higher frequency than what it actually is. And it tells us the beats disappear, so the beat frequency goes to 0. 498 is the only one that, if it increased, could end up equaling 500. So if the beats disappear, that means the beat frequency is 0. So F1 and F2 have to be the same in that case. So moving towards us, the 498, we would hear something higher, so we could hear 500, and then we would not hear beats. If we had 502 and it moved towards us, we would hear something even higher than 502. And so the difference between the source 1, 500, and something bigger than 502 is going to be something even bigger. So the beat frequency would increase had source 2 been 502 hertz. Okay. And interestingly enough, you could figure out how fast source 2 had to move towards you, right? F plus minus, the frequency we hear would need to be the 500. The actual frequency is 498. So you could set up the Doppler equation and find out how fast that source was moving if you wanted to. Okay.